What's up, math scholars? It's Veterans Day. How many of you went to the Veterans Day thing first period? It was kind of nice. The trumpet played the taps, and they read a little essay winner about what Veterans Day means to me that a high school student wrote. It's cool. All right, so we're doing 3.7 using function notation. Who's excited? Woo! All right, so we call this thing a function machine because something comes in and all this stuff happens and then something else comes out. So a function can be thought of a machine that assigns a output to every input. You're going to put something in, something's going to happen, and the answer's going to come back out. So an x is called the input, and the f of x is the same exact thing as y, and that's the output. So this f just means function, and the x just means the independent variable that you'll be plugging into the function. Oh, yeah, I'm staying on this slide. I'm actually not leaving the slide. It says, find and illustrate f of 2 using the function machine. So basically, we're going to be putting a 2 in the function, and we're going to be calculating 3 times 2 plus 4. Do you see how I placed a 2 in for x? What would that answer be? 10. There you go. So the 2 was called the input, 10 was called the output, 2 is the x value, 10 is the y value. Let's do the same thing with the negative 1. We're going to find f of negative 1. So put a negative 1 in place of x. So the math will be 3 times negative 1 plus 4. What's that answer going to end up being? Sure. Or you could just write that f of 2 equals 10. And what does f of negative 1 equal? 3 times negative 1 plus 4. Can you do that in your head? No, it's not 7. 3 times negative 1 is negative 3. Now we're adding the 4. 1. Yes. So the way you could write that is you could write f of 2 equals 10 and f of negative 1 equals 1. Does that make sense? So when I put a 2 in the function, I got a 10. When I put a negative 1 in the function, I got a 1.
So basically just
plug a 2 in for x, yeah. Okay. I went ahead, the question was why they have weird boxes. Most of the time they won't have weird boxes. That was just some sort of graphic organizer thing that some math teacher thought was cool. But this is what most of them will look like. They'll give you the function. They're not always called f of x. This particular one's p of x. And then they'll have you do something with the function. And in this case, they want you to find p of 2. So what would I do? You would do math. You're right. But what would I do more specifically? Jose?
Man,
Ava?
like solve for put 2 in for x, so it'd be 5. Yeah, and then 2, and then minus 4.
Yeah. So if you guys need a calculator, grab it. I'm grabbing mine. Nick got it. 5.2 times 2 minus 4. What did Nick get? 6.4. Perfect. So P of 2 equals 6.4. The input was 2. The output was 6.4. This is the 2 is our x. The 6.4 was our y, basically. Okay. I think it's time for a board buddy, so I'm going to send up 8 people for this one. Hey, all 8 people I called up looked like they were super scholars. They put their negative 3 in for x, plugged it in their calculator, got negative 9.6. Any questions? We all have calculators. We're doing these on our calculators. All right. There's a lot on here. Let's just do the left-hand column. Let's ignore what's under there for now. Let me explain what we see before we send people up. We've got an f of x function. That's going to be an x squared plus 3. But then we have a g of x function. That's going to be x plus 1. So when you're given a number, you want to make sure you're putting it in the right spot. So in this first one, where would I put that 3? In the function f. So the equation would be 3 squared plus 3. What's 3 squared plus 3? plug and chug. 12, very good. Now my second one is g of 3. So that means go to function g. Found it. It's over here. I would put the 3 in frets. It would be 3 plus 1. What would that be? Good. So I'm going to hit pause in the video and have some scholars come up and do these last two. F of -2 and then g of 0. Okay? All right. I love overhearing board buddy conversations. Ken, in this case, was the one up here being a scholar. He's like, wait a minute. -2 times -2 would make a +4. And I'm like, you better listen to that guy. He's being a scholar right now. So it is 7. Now, if you're having trouble on your calculator, you're like, Mrs. Hart, my calculator is telling me the answer is not 7. My calculator is telling me my answer is -1. Then you're typing it in wrong. You got to type it in with the parentheses exactly as I have it written right there, or the calculator will not calculate -2 times -2 correctly. And then the last one would be a 1. Okay? What are you doing back there? Okay. Alright, we're going to try these ones over here together because they're getting a little strange, getting a little harder. Face forward, everybody. Okay, we're over here. The problems are getting a little bigger, so we're going to talk together on how they work. First off, we have f of 2 plus g of 1. So you're actually going to find f of 2 first by putting a 2 in the formula here. What would that be? 2 squared plus 3. 7. And then you're going to find g of 1 by putting a 1 right there. What would that be? And then you're going to add up the result of f of 2 plus the result of f of g of 1. 9. Did you follow how that works? All right, I'll pause and I want you to try this one all by yourself. G of -1 plus f of 1. All right, so this next one, Anthony's like, I don't get it. How are we going to put a y in and get a number as an answer? We're not. We're not going to be able to get a number as an answer. If they start you off with a variable, you're going to have an answer with variables in it. So it'll look like some sort of expression or an equation.
Y squared plus 3 is
Good.
the answer.
So yeah, so what you're going to do is you're going to put a y in place of x right there. So your answer is just y squared plus 3. You can't really do anything more with that. That kid's a scholar. Okay, so can we have somebody who's feeling scholarly give the next one a try? Ken?
Okay, so you should make scholar buttons.
Like when you push the easy button, like that kid's a scholar. You push the button, it says that kid's a scholar. All right, Ken, sorry to interrupt you. You're going to put that W, where are you going to put it? Which equation? Right, so what will the answer look like? Good job, what a scholar. Very good. All right, so this is a little bit different. Here's what they're asking. Let's read the instructions. Find the value of x so that the function has the given value. So they're basically saying we don't know what x is, but we know that the final answer is 40. Do you know how we could set this up, Ken? And then what do I do with the 40? What do I do with the 40? Set it equal. So basically we know the solution is 40, but we don't know what the x value was. So we're just going to set our equation equal to 40 and solve. Yes, what would I do first to solve? Plus 15. All right, he remembers all his solving skills. That's 55, and then what? Yeah, so I'm glad you remember how to solve the equation. So basically, they had put a 5 in for x if they had gotten 40 as their answer. Do you understand the concept enough that we could send 8 people up to the board? Okay.
Let's go.
They pause the video. Here's the problem if you're at home watching the video that you can give this a try. We're going to have board buddies come up. Okay, so our scholars came on up. It looks like they... Hey, real quick, this is... Hey, we're on video. This is just me being like a picky math teacher. I'm interpreting their work. I do save this work on the internet, so I want it looking pristine and perfect. What do you think my complaint is with the way they've written this?
It's uneven.
It looks like they're dividing, and they're not dividing. I mean, they're doing the math right, they're writing it wrong.
Right.
So you want to do a minus 14, not a divide by 14? We're on the video. 26 minus 14 is 12. Now, I love how they wrote this. Divide both sides by -4. So basically, x was -3. Very good work. We have something called a parent function. A parent linear function is just the most basic line you can ever draw. Here's its equation. So I have a couple questions for you. What is the slope of that equation? It's an invisible one that's living right about there. And what's the y-intercept to that equation?
0.
Good. So that's why it's very basic. Slope of 1, intercept of 0. Every line from here on out, we're going to be comparing to this parent function. Intercept of 0, slope of 1. Okay, and we're going to say, how is this different from the parent function? Does that make sense?
No.
I don't think you're ready for the test quite yet. Maybe a couple study parties first. Okay, so it says graph the function and compare it with the parent function. So let's just look. Here was our parent. It had a slope of 1 and an intercept of 0. How does this compare? Let's look at the slope first. Is it a different slope or the same, Ken?
It's the same.
So the slope is still 1. What is different?
+4.
Good. So on my original parent function started at 0 and it had a slope of 1, right?
Yeah.
This one's going to start off at 4 and still have a slope of 1. Are they parallel?
Yes.
Very good. Yep, they have the same slope. The slope is 1. Same slope. They're parallel. Different y-intercept. Okay? Make sense? Any questions?
Yeah.
How would this one compare to the parent function? Ken?
Would it be like, it'll start at 3 and then
No. So this one actually has a y-intercept of 0,
So
as did this, but what's the difference? A much steeper slope. So my parent function has that slope of 1 and the intercept of 0. This would share the intercept, but it's going to be a lot steeper. 3 over 1. 1, 2, 3, 1. 1, 2, 3, 1. Do you see the visual difference? It's much steeper. 1, 2, 3, 1. 1, 2, 3, 1.
Oh.
Okay?
That's not easier, is it?
Thank you, light up my world like no
No,
fire.
pink boyfriend might just be.
Okay. This will be our last slide of the day. I was looking at the homework, and there's some problems in the homework with this instructions. Find the range of each function for the given domain. And I want you to know what that means. So what does the word range mean?
I don't know.
Y values. So they're basically saying find the y values for the given x values of the function. I should have said x, sorry. So let me give you a function. I'll give you a very easy function. How about x plus 7? So they're going to provide a function to you. Then they're going to provide a 3-number domain to you. Maybe -5, 0, and 5. And we need to find the range. Let's talk about how we can make that happen.
Wait, hold on. I'm so confused.
Okay, well that's why I added this slide on, because there's some homework problems like this. They're saying find the y values of each function for the given x values. So if these are all domains, this is a list of x values. We're going to find their corresponding y values. So basically, if I plug in -5 for x, what would I get for y?
Wait, what number is that?
-5 plus 7.
Mm-hmm. So 2, right? -5 plus 7 is 2.
Oh, so that's what you put for the range is the answer.
Right, now we're going to do this as an x value too. If I put a 0 in for x, what would I get for y? And if I put a 5 in for x, what would I get for y? And that would be your answer for this. It's a little different look visually, but it's the same exact thing we've been doing as far as plugging in and calculating out y values. Does that make sense? So the homework is a worksheet I'm about to pass out. If you lose the paper, I'll be sure to get a copy of it into Polaris, okay?